Hi everyone, this is Terry. I'm your course instructor, and this is the Intro to OChem Lab pre-lab talk. And also some safety reminders. This is the short version, and there's the complete version on Canvas and how this course works. A PowerPoint giving you all the COVID and safety information, and you should watch that before you come to class too. But here's the short version. Wash your hands when you enter the lab classroom, put on your PPE, spray your bench top with the provided isopropanol and wipe with paper towels. Take off PPE before leaving the classroom and wash your hands again. And as I just said, watch the COVID and safety PowerPoint on Canvas. Okay, now let's go over today's experiment. The purpose of today's experiment is to review SN1 versus SN2 reactions, their mechanisms, and what conditions favor each. Hopefully you remember that SN1 and SN2 are type of nucleophilic substitution reactions. Today's reaction, ROH plus HCl goes to RCl plus water, is an example of a nucleophilic substitution. And your job is to figure out whether it's SN1 or SN2. Okay, so there are some basic things that you should know. For example, for this reaction, what is the substrate? Hopefully you picked alcohol. The ROH is the substrate. And what is the nucleophile? Okay, the nucleophile comes from the HCl, and it's actually the chloride, Cl minus ion. And the leaving group? The leaving group is actually water, which comes from the protonated OH group of the alcohol. If these things are not ringing a bell with you, you really should do a little bit of review by watching the tutorial available on Canvas and or rereading that section in your lecture notebook. Your lecture textbook, sorry. Okay, so how do we know whether today's reaction is SN1 or SN2? Okay, let's start with SN2. Okay, the 2 reminds us that there are 2 compounds in the rate determining step. And actually the mechanism for SN2 is very easy, I shouldn't say easy, very simple. You have substrate with the leaving group, and you have a nucleophile, and in a single step, the nucleophile attacks the substrate, and the leaving group leaves. You end up with R with now N, and the leaving group off by itself. Okay, SN1, and the 1 reminds us that there is a single compound in the rate determining step, has 2 steps. In the first step, the leaving group leaves to give a carbocation, and then the nucleophile attacks the carbocation in the second step. The first step is the rate determining step. Okay, so now that we know the 2 mechanisms, we can ask some questions about today's reaction. But before we do that, since our substrate is an alcohol, we need to remember what primary, secondary, and tertiary alcohols are. This is a review from OChem 1, so hopefully you remember this. Okay, so alcohol has an OH group, of course, and for a primary alcohol, the carbon that's attached to the OH group is attached to no more than 1 R group. For secondary alcohol, the carbon attached to the OH group is attached to 2 R groups. And for tertiary alcohol, I'm sure you've guessed by now, or know by now, remember by now, the carbon attached to the OH group is also attached to 3 R groups. Okay, so hopefully you remember which of these forms the most stable carbocation. That would be tertiary, because you have 3 R groups, and each of these R groups have some electron donating properties, and that helps stabilize the carbocation. So if today's reaction, the ROH plus the HCl gives RCl plus water, works the best for primary alcohols, would it be SN1 or SN2? Okay, let's go back to our mechanism. So for SN1, you form a carbocation, and primary alcohols do not form a stable carbocation, so that would mean that they favor SN2. Okay, on the other hand, if today's reaction works the best for tertiary alcohols, is it SN1 or SN2? As we just talked about, SN1 mechanism involves the formation of a carbocation, and tertiary alcohols form the most stable carbocation. So if today's reaction works the best for tertiary alcohols, it's got to be SN1. Okay, so these are the alcohols that we're using for today's experiment. Okay, let's draw the bond line structure for each of these. So 1 butanol, butanol is 4 carbons, so 1, 2, 3, 4. And since it's 1 butanol, the OH group is attached to the first carbon. And since the carbon attached to the OH group is only attached to one other R group, this one right here, then that would make it primary. And then we have 2 butanol, 1, 2, 3, 4. OH group is attached to the second carbon. So the carbon attached to the OH group is attached to 1, 2 R groups. So that means this guy is secondary. And then we have 2 methyl, 1 propanol. Propanol is 3, or prop is 3. 1, 2, 3. 2 methyl, 1, 2. So we need a methyl group here. 1 propanol. OH gets attached to the first carbon. So if you look at the carbon attached to the OH group, it's only attached to one other R group. So this is also primary, even though it's got this branch part. But this branch part isn't directly connected to this carbon, so it's still primary. And then tert-butanol. Hopefully you remember that tert-butanol looks like this. So this is the carbon attached to the OH group, and then we have 1, 2, 3 R groups, so that makes this tertiary. So depending on whether the reaction works the best with the tertiary or the primary alcohols, you can figure out which mechanism it is. Okay, so today you're working with what's called the Lucas reagent, which is concentrated HCl and the zinc chloride. And the zinc chloride just helps the reaction to work a little bit better. And cloudy is evidence that the reaction worked. Because if you form the alkyl chloride, it's less soluble than the alcohol that you started with. So the alkyl chloride makes the solution cloudy. So for safety today, you need to be very careful when you're handling the Lucas reagent. It's very corrosive because of the concentrated HCl. So just, use common sense, wear your PPE, don't be lifting your glasses off your face, work in the hood, and if you spill any on you, rinse with water immediately, and if it's significant amount, then please call your TA. A couple of notes about the procedure. It's a very simple procedure, but it's very important to follow it as written or you can get false positives. And as a reminder, do come prepared, but still ask your TA if you're unsure about anything. When you're finished, rinse the test tubes with a little bit of acetone and put them in broken glass since they're disposable. Droppers without chemicals into the plastic waste container. And chemical waste goes into the chemical waste jars in the waste hood, and the acetone for rinsing is also in there. Make sure you log out of any application that you logged into, plug in your iPad, and return the crayon when you leave. And also make sure you wash your hands to help with COVID, keeping everyone safe from COVID.